Hello and welcome to day 12, or day after 12. Sorry, I got home very late, just did the puzzle and went to bed. Anyway, so today's puzzle, we have some sort of hashes and periods, and we have a checksum kind of, I guess, that uses, it tells us how many hashes we have. So this is 1, 1, 3. This one's also 1, 1, 3. The number of periods does not matter, just the number of hashes. However, our actual input is corrupted, supposedly, so we don't know specifically some of the characters. So anything that's a question mark could be a period or could be a hash. So the question is how many ways can we produce data and get a valid answer that matches the checksum? So in this case, 1, 1, 3, there's still only one option. It has to be 1, it has to be 1, because there has to be a period here, otherwise you would have 3 or 2 or something instead of 1, 1, 3. And so this one, same thing. The first one could go either here or here, but it can't go on both question marks. And the second one would have to go either here or here. It can't go on both question marks. The third part, this question mark has to be a hash because it's a 3. So we know that that's a whole set. So there's 2 possibilities here, and there's 2 possibilities here, which gives us a total of 4 different possibilities. So basically, we just want to go through there and find how many there are. Part 1 was pretty quick for me because I just decided to use recursion, which I knew was going to bite me later, which it did, but we'll get to that in a second. So recursion was basically just, I'm going to replace the first question mark with a dot, and then I'm going to check if that, recursively check to see if that's valid, and then add that to same thing with replacing it with a hash instead of a period. And then each line, basically the base case, the basement is if there are no question marks, if it's valid, we increment by 1. If it's not, we don't. And then I also wrote an isValid function to help with that. So if it contains a question mark, probably redundant in this case, but no. And then otherwise we're going to split it and then filter in those links, and then we're going to return if they match or not. So pretty simple on that part. And then that works fine for part 1. It takes a few seconds, but it's fine. So for part 2, they frequently will have us do something that's either more complex or something that's way more processing intensive, so that your bad algorithms like recursion don't necessarily work. And today's was the latter. So the idea is basically we're going to take the same thing and we're going to repeat it up to 5 times per line. So like this line, if this was a line, dot period, would now become dot period with a question mark in between, dot period, question mark, and it would be repeated 5 times, and the 1 would be repeated 5 times. That's not so bad when it's like this. But the problem is when you have something that's like this, and that becomes, instead of it being 15 characters, now it's 75 characters. I think the highest I had was 20, so it would be 100 characters or something like that, that have a lot of question marks in them. You know, and then you wind up having millions of values in a single one or more, and you just can't do that in recursion in a reasonable amount of time. So what I wound up doing is, the input's not too bad. I'm just going to add a question mark, repeat it 5 times, remove the last question mark, only want 4, and then duplicate matches, no problem. So that takes care of that. But then what I want to do for positions, or for the count, first I made a new helper function that basically gives me a list of all positions that the next number could come in. So if the next number is, say, a 1, it's going to go through there and find every location that a 1 could be the next number. Now, it does not do anything else extra smart about it, so you know, if there's 10 more things in the list to check for, it could still return you the last element. It's just going to fail elsewhere instead. All it's going to do is just find locations for the next possible number, and to return that as a list. And then I've got another function here that basically we're going to go through and check a whole bunch of stuff. So in certain cases I care that's a 1, certain cases I care that's not a 1. I'm not going to go through all the edge cases. There's probably a much better way to collapse all this into some logic that makes sense. And I'll probably go through there and do that at some point. Of course, if I do, the newest code is in the GitHub as always. But then at which point what I'm doing is each step I'm taking off the chunk that we have not changed since the one, or since adding the new character, and then adding the new character, and then sending in the last chunk recursively. So it's sort of dynamic programming on that, and that each time we're basically building up a list of potential solutions versus going through straight recursion, but then it's also sort of recursion-y because I'm still breaking the problem down each time. It's fine. Anyway, so, but if you think about like this, like, let me grab one of these inputs or whatever here. So if I have something like this, then like this first number is a 3, so it's going to go through here, and like this is the first position that you have a 3 is right here because it is, and then it's going to basically take all of this off and then send all of this in with the remaining of the list, which is 2, 1, and then it repeats, whatever. And then it'll do the same thing over and over again. But then after that, it'll try the 3 again over here, or here, and send in the rest of the list again, and so forth, over and over. So it'll try the 3 and then send in the 2, 1, 3, 2, 1, 3, whatever here, etc. So every time it does the recursion, at least, the list gets quite a bit smaller pretty quickly. And then it was still taking a little bit of time to run. Part of that is, though, that we're redoing a lot of data, especially at the ends of lines. So there's a lot of lines that inside the same line, we're going to do the end of the line many, many times. So like the beginning of the line, we only do a couple of times because once we pass that position, we don't ever look at it again. But the end of the line, every single check that we have is just going to keep going to the end of the line again and again and again. And then of course we can have a lot of repeats and stuff too. So there's, 1,000 something entries. A lot of them probably end with question, 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 for example. So then we just do a lookup table to memorization basically. So I take the remainder of the line and then the remainder of our matches, I'm just going to join them with a comma and just shove it on the end of the line. It doesn't matter, it just has to be unique. So the line and match combination is unique for every time this is run. And if we've seen it, boom, calculate it, we're done. And if we haven't seen it, don't calculate it, it's fine. And so like you get a lot of the end pieces, you get a little bit of boost many, many times. But at the same time, like this whole end piece, again, if we copy that 5 times or whatever, then you can see how many times like this end piece is going to get called over and over and over again. So the more times we call it, the fewer times we actually have to go through it when we see it. So once it did that, got down to running pretty quickly here. I think the first part is still actually longer. So yeah, first part took 2.5 seconds, last part just under 1 second. I'm sure there's ways to make that cleaner and better, and maybe I'll go back and do that, but works for me. If you have any questions, of course, hit me up in the comments below. News hubs or codes on the GitHub as always, and other than that, I'll see you tomorrow.